Okay, let's just put this out there. If you're still using nested loops for subarray problems, you're wasting time. Consider that your tough love reality check for today from your interview coach. Look, when you're sitting in the hot seat during a technical interview, every single second counts, and every ounce of computing power you waste is a massive red flag to your interviewer. If your very first instinct is to just throw a nested loop at an array problem, we need to completely rewire your thinking right now. Because honestly, that approach is going to cost you time, and ultimately, it could cost you the job offer. Welcome to today's Explainer. We are taking you from brute force to completely optimal by mastering one of the absolute most powerful concepts in your algorithmic toolkit, the sliding window technique. I'm your coach, and my goal today is to completely demystify this critical technique for you. I see so many candidates just absolutely freeze up when they see subarray problems, but by the end of our time together, you're going to see how beautifully logical this really is. You're going to walk into your next technical interview feeling confident, prepared, and totally ready to ace it. Here is our training plan for today. 1. Ditch the nested loops. 2. Meet the sliding window. 3. Fixed versus variable windows. 4. The rookie mistake. And 5. Your winning template. Take a deep breath and let's jump right in. Section 1. Ditch the nested loops. So here's the very first fundamental shift in mindset you need to succeed at subarray problems. We've got to break some old bad coding habits. Brute force methods waste time on redundant computation. Actually, think about that phrase for a second, redundant computation. When you use a nested loop to check every single possible subarray, you are repeatedly looking at the exact same elements over and over again. You calculate a sum, and then literally on the very next iteration, you calculate like 90% of that exact same sum right from scratch. It's a massive performance bottleneck. In an interview, your interviewer is watching closely to see if you catch that inefficiency. Nested loops will give you an O of n squared time complexity, and in the highly competitive world of software engineering, that simply won't cut it.
Section 2. Meet the sliding window.
So how exactly do we fix the nested loop problem? Well, enter the sliding window. It's a technique where you maintain a window of elements and you literally slide it across the array, completely avoiding that redundant computation. This right here is the game-changing technique that'll entirely replace those slow, repetitive, nested loops and instantly elevate your code to optimal performance. Think of it for a second like you're looking at a super long line of parked cars through a camera viewfinder, or maybe just a sliding picture frame. Your viewfinder can only see, let's say, 3 cars at a time. To see the next set of cars, you don't dismantle the camera and rebuild a new one. No, you just pan the camera one spot to the right. One new car enters your view on the right, and one old car leaves your view on the left. The cars in the middle, they stayed exactly where they were. You kept the visual perfectly clear without doing any extra work at all. That is the magic of the sliding window. It just glides along the data. Section 3. Fixed versus variable windows. All right, let's see how this actually translates into the real interview questions you're absolutely going to face when you're in the hot seat. We've got 2 main variations. First, let's look at the fixed window. This is when the window size, which is usually denoted as K, is just handed to you right in the problem description. Think of this exactly like that rigid camera viewfinder we just talked about. It never changes size. You compute the initial window of size K, and then you just slide it. You add the new element on the right and remove the old element on the left. Simple. But then we have the variable window. And man, this is the one that really trips people up. In a variable window problem, this size is not given to you. Instead, you expand to the right and you shrink from the left based on a specific condition. Imagine this not like a rigid camera frame, but more like an accordion. You stretch the accordion out to the right to grab more elements, but the split second you hit a roadblock, like a broken condition, you squeeze that accordion from the left side. You shrink it down until the condition is valid again. It's dynamic, it breathes, and it's constantly adjusting.
So your success really comes down to mastering this 2-step variable window logic. Step 1, expand right until the condition breaks. Step 2, shrink from the left. This exact 1-2 punch is what you'll use for those notoriously tricky interview questions, like finding the longest substring without repeating characters. You stretch your accordion out, adding letters one by one on the right, but the absolute moment you add a letter you've already seen, bam, condition broken. You stop expanding immediately, and you start pulling the left side of your accordion in, dropping letters until that duplicate is gone. Once it's gone, you just resume expanding. Honestly, it's an incredibly elegant dance once you get the hang of it. Now, while you're managing this accordion, you're going to need some tools inside the window to keep track of what you're actually looking at. These are your essential data structures. You'll commonly use a HashMap to keep track of frequency counts, which lets you instantly know if you've seen a character before. Or for the slightly more advanced problems, you might use a Deque, specifically a monotonic Deque, to efficiently track the maximum or minimum values currently sitting inside your window. Just think of these as the dashboard instruments inside your sliding car, giving you a real-time reading of your current state.
Section 4. The rookie mistake.
Okay, as your coach, I have to warn you about the single most common fumble I see when candidates are under pressure at the whiteboard. Whatever you do, do not reset your window from scratch. Seriously, this completely defeats the entire purpose of the technique. If you hit a broken condition and you suddenly clear out your current window and start a brand new nested loop, you've just fallen straight back into the brute force trap. Remember the camera viewfinder. The whole point here is the massive performance benefit of reusing your previous computation. You only update what actually changed. You add exactly one element on the right, and you remove exactly one element on the left. That's the whole shebang. You are mathematically just taking your previous total, adding a number, and subtracting a number. Doing this turns an O of n squared nightmare into a beautifully optimized O of n sweep.
Section 5. Your winning interview template.
I am about to hand over the ultimate game-winning cheat sheet. Seriously, if you memorize this, you will never freeze up at the whiteboard again when facing a subarray problem. Let's walk through this core logic template bullet by bullet. Normally, it's not some intimidating wall of code, it's just a simple, manageable checklist. First up, you initialize your pointers. Int left equals 0, right equals 0. Basically, your window starts closed. Next is your main loop, while right is less than n. You're just going to march that right pointer all the way to the end of the array. Inside the loop, the very first thing you do is add. You bring r of right into your window state. You expand the accordion. Then comes the real magic inner loop, the shrink phase, while condition broken. If adding that element messed things up, you simply remove r of left from your state, and you do left plus plus. You just pull that left side of the accordion in until things are valid again. Once the condition is valid, you confidently update your answer. Maybe that's checking if this is the longest window you've seen so far. And finally, right plus plus. You step forward to repeat the whole process. This template right here is your anchor. It handles the expanding, the shrinking, and the updating in a perfectly logical flow.
So, I want to leave you with this final question. Are you ready to claim your free points? Look, sliding window problems honestly feel incredibly hard and intimidating, right up until the exact moment you internalize the template we just covered. But after that, after you truly understand the camera sliding, the accordion stretching, and the absolute necessity of reusing your computation, they honestly just feel like free points on the board. You know the mechanics now. You know exactly what pitfalls to avoid, and you've got the winning template. So go get out there and absolutely crush your next interview.